In the safe, unsafe driving application, the video image on the left is used for training the classifier. The video image on the right is used to give driving commands to the robot. When placed in a new environment, the first thing we must do is train the classifier. Clicking and dragging with the right mouse button will mark an area of the image as unsafe. Using the left mouse button will mark an area as safe. With the training examples given so far, these areas along the edge of the image have been classified as unsafe. In this particular situation, this misclassification doesn't have a strong effect on the robot's driving algorithm. The same is true of these two smaller unsafe regions. At some point, it might be necessary to mark the walls as unsafe. However, there is a strong area of unsafe between the floor and the wall, which would help the robot avoid the wall. If we wanted a more accurate classifier, we could simply give it more training data. Since our desired path is being classified as mostly safe, we will start driving. Clicking on the right video image causes the robot to turn towards and move to the point clicked on. Clicking on the blind turning circle causes the robot to turn farther than the camera is able to see. These boxes were classified as mostly safe. To improve the classifier's accuracy, we simply mark the boxes as unsafe. The boxes are now correctly classified as unsafe and can be avoided. We click again on the right video image to tell the robot to continue driving. The robot is now able to avoid the correctly classified boxes. One final drive command gets the robot past the boxes and to the desired destination. Here the robot is in an environment where the unsafe areas are fairly diverse. We tell the classifier that the carpet is safe and that the surrounding obstacles are unsafe. We give it one more unsafe example. We then tell the robot to drive forward. It first turns to avoid the table, and then turns to avoid the chair. Part of the wall is classified as safe, but the area of unsafe along the bottom of the wall causes the robot to stop. Here the robot has been placed in an outdoor environment. In this situation, we want the robot to stay on the sidewalk. So, we mark the sidewalk as safe, and the grass and people as unsafe. We then tell the robot to drive forward. The robot turns to avoid the grass. Notice that the classifier already does reasonably well at classifying the people as unsafe. We now turn the robot to go around the corner and continue down another sidewalk. Here the classifier marks the grass as unsafe, but marks the snow as safe. We stop the robot and give the classifier a few more training examples. The classifier now marks the snow as mostly unsafe. We tell the robot to go forward, and it is now able to avoid the snow. In a parking lot, we mark the asphalt as safe, and the cars as unsafe. We add another unsafe example to make the classification of the cars more accurate, and then drive forward. The robot is able to avoid the car. We drive again. This misclassified area is causing the robot to turn unnecessarily. To correct it, we simply add a few more examples.